All right, let's work on the review and preview problem, starting with 646. It says to copy the diagram below on your paper and gives us the angle measurements for A and G, and they want us to find the measures of each labeled angle. Explain how you find each angle, citing definitions and theorems from your toolkit that support your steps. Remember, you can find the angles in any order depending on the relationships that you use. Okay, so let's just start with what they tell us. They tell us that A is 53 degrees and G is 125. So there's a lot of different ways we could start here. One thing I notice is that, let's see, B and G together, I notice make 180 degrees, right? So B is going to be 180 minus 125, which is going to be, let's see, 55 degrees. Because they are, let's see, B and G are supplementary. Great. Okay, let's think about a different angle. Let's see, I notice that I have got two parallel lines here, and we could think of this as a transversal. I notice that B and E are interior to those two parallel lines and on alternate sides of the transversal. So E and B are alternate interior angles, and because those lines are parallel, we know that they are congruent. So we could say B and E are alternate interior angles. You could write it out in your homework. And congruent because the lines are parallel. All right, let's see what else we can figure out here. I notice that I've got a triangle going on, right? And I know that by the triangle sum theorem that the angles of a triangle add up to 180 degrees. So if I said 180 minus 53 minus 55, that's going to give me angle C. And it turns out that that is 72 degrees. So I could say that equals angle C by the triangle sum theorem. All right, what do I have left? F. Well, maybe I'm trying to think of an interesting order to do things. Let's see, I know that A and D are also alternate interior angles. So we could say, I know that D is going to be 53 degrees because A and D are alternate interior and congruent because the lines are parallel. Another way I could think about that is just say, well, together, those three angles are supplementary, right? That would give me the same value. Just to try something different, I do notice that, let's see, F and A are supplementary, but let's make this interesting. D and F are same side interior angles. And what do we know about interior angles? Oops. If the lines are parallel, we know that alternate interior angles are supplementary. So 180 degrees minus 53 is going to give me 127 for my angle F. All right. Problem 47, as Simone looked at the triangles below, she said, I think these triangles are congruent. Her teammate Darla said, but they don't look the same. How can you tell? Simone smiled and said, never trust the picture. Look at the angles and the sides. The measures are all the same. Solve for the missing side of each triangle. How do they compare? All right, so I notice that, what do we know? We have two sides here. One is double the other, and they are, this angle between them is 60 degrees. Okay, if we have that situation, if we have 3 times 2 is 6, I know that I have, and this angle between them is 60 degrees. Can I find the third side? I can. Do I know right away that this is a right triangle? It is going to turn out to be a 30, 60, 90 triangle. The relationship between these two sides with a 60-degree angle in between them, it turns out that this is going to be the 6 is going to be the hypotenuse, 30 is that leg, and I know, so this is going to be a right angle, even though it doesn't look like it. Like she said, don't trust the picture, because that relationship is, this 6 is twice as long as 3, and 60 degrees is the angle between them. I know that this is going to be a 30, 60, 90 triangle, and this other side is going to be that special leg times the square root of 3. Is that enough to know that these two triangles are similar? Well, let's see, these two sides have a side ratio of 1. These two sides have a side ratio of 1, and these two angles are congruent. So, yes, so because we know all of those things match, we know that this side is also going to be 3. We could even make a little flowchart proof. We could say that the ratio of 3 to 3 is 1, and the side ratio of 3 squared of 3 over 3 squared of 3 is 1. And we know that 30 degrees equals 30 degrees. So we could say that the triangles are similar, and actually more than similar, right? The triangles are congruent because of side, angle, side congruence. All right, so let's look at problem 48. Write a converse for each conditional statement below. Then, assuming the original statement is true, decide if the converse must be true or not. Okay, so let's zoom in here. So the first one, remember, for finding converses, we are going to just swap the order in the sentence if-then statements. We're going to swap the two clauses, and we're going to say if the ground is wet, then it rained. What do you think? Is that always true? If the ground is wet, then it rained? I mean, what if the sprinklers went on? What if somebody dumped a bucket of water? Right? I would say that's not always true. Sometimes that could be false. Could be true, but it also could be false. All right, here are two phrases. If a polygon is a square, then it is a rectangle. Okay, so swapping them. If a polygon is a rectangle, then it is a square. What do you think? Is every rectangle a square? Let's see, this one was false. I can think of rectangles that are not squares, right? Sometimes two of the sides are longer than others. That is not always true. All right, how about this one? If a polygon has 4 90-degree angles, then it is a rectangle. What do you think? Is that true? If it has 4 90-degree angles, then it is a rectangle? I would say yes, that is going to be true, right? That is the definition of a rectangle. All right, if the shape has 3 angles, it is a triangle. All right, let's flip these. If a shape is a triangle, then it has 3 angles. Is that always true? Yep, every triangle has three angles. Okay, now we're going to swap these. If 2 lines intersect, then vertical angles are congruent. If vertical angles are congruent, then 2 lines intersect. I can't think of a way to get vertical angles without two lines intersecting. So, yep, I think that's true. So you can see sometimes the converses of true statements are true or false, and sometimes they're true. It's just, you got to look at the statements and make your best judgment. All right, problem 49. On graph paper, graph the line y equals -3/2 x plus 6. Name the x and y intercepts. Okay, so this is going to give us our starting point, our y-intercept here. So +6, I'm sure I go along the y-axis to +6, and this tells me my slope, -3/2. So from my starting point, I'm going to go down 1, 2, 3, and over 2 to get another point. And I'm going to do it again. I'm going to go down 1, 2, 3, and over to the right, 1, 2. And I could do it one more time. 1, 2, 3, over 2. Of course, I only have to do it for 2 points, but I can do it for more. And then I do my best to connect those in a straight line. And there's my line. The x and y intercept. So the x-intercept happens where it intersects the x-axis, so that's going to happen right there. And I'm going to write that as 4, 0. And my y-intercept happens there. My y-intercept happens at the point 0, 6. All right, problem 50. This is a checkpoint, so we want to be super sure that you feel confident with this. This is a checkpoint for solving proportional equations and similar figures. Okay, so let's look at A. We've got a ratio here. I think the easiest way to solve ratios is by cross multiplying, right? We call that the butterfly method sometimes. So I'm going to say 5 times 3 equals 4 times 7 minus y. Okay, now I just have an equation to solve. So let's see, I get 15 equals 28 minus 4y, right? I distribute the 4 to both of those terms. And let's see, I'll subtract 28 from both sides. 15 minus 28 gives me a -13 equals -4y. And now I want to solve for y. I'll divide both sides by -4 to get that y equals +13/4. Okay, how about this one? Let's zoom in. Again, I'm going to use my butterfly method. Y times 6, 3 times y minus 2. So 3 times y minus 2 equals 6y. Okay, I'm going to distribute my 3 to both terms, so I get 3y minus 6 equals 6y. All right, let's see, I'll subtract 3y from both sides, and I get -6 equals 3y. And now to solve for y, I'll divide both sides by 3, and I get that -2 equals y. And of course, we could always check our answers here, right? I could substitute -2 back in. I could say 3 over -2 equals 6 over -4. And yeah, it looks like those are equal to each other. How about if I did that over here? Well, it's going to be a little bit trickier with a fraction, right? Okay, part B, Sam grew 1 3/4 inches in 4.5 months. If he continued at the same rate, how much would he grow in 1 year? Okay, so I'm going to write my mixed numbers just as decimals here. I'm going to say, okay, in 1.75, he grew 1.75 inches per 4.5 months. If that rate is the same as 12 months, so 4.5 and 12 are both months, so I'm going to put those in the bottom there. How much would he grow? Okay, so then I'm going to cross multiply, use the butterfly method again. I'm going to get 4.5x equals 12 times 1.75. Okay, 12 times 1.75 is 21. And then I'll divide both sides by 4.5. And I get that x equals 4.67 inches. Does that seem reasonable? I mean, that'd be a lot to grow in a year, but if he continued at the same rate, that's what he would do. All right, part D, use the figure at right to solve for x. Okay, so let's zoom in here on this figure. We want to solve for x. Anytime we have one triangle inside of another, I strongly recommend that you separate them out. Draw two separate triangles, the smaller one and the bigger one, and let's label everything we can. Let's see, in the smaller one, we know this side is 3, this side is x, and that side is 4. And in the bigger one, we know that this side is 12. What's this side here? That's going to be 8 plus x, right? What else could we label here? Do we know anything about angles? Well, this angle is going to be common. It's the exact same angle right here and right here. So I'm going to label those angles that match. Are there any other angles that I know? Well, I do notice these two lines are parallel, right? So if those lines are parallel, this angle is corresponding to that one, right? I could slide it down that transversal. So these two angles also match. So is that enough to know that these two triangles are similar? It is, by angle-angle similarity, right? Okay, so if those two angles are similar, I know that this side corresponds to 12 and this side corresponds to 8 plus x. So let me write some ratios. I'm going to say 4 over 12 equals x over 8 plus x. Okay, this is a ratio. I can solve this using the butterfly method. Right, I'll cross multiply 12x equals 4 times 8 plus x. Okay, I'm going to distribute my 4. 12x equals 32 plus 4x. Let's see, I could subtract 4x from both sides. I get 8x equals 32. Divide both sides by 8. 32 divided by 8 is 4. Okay, so that would be my solution. So I had to recognize and prove, really, in my own mind that these two triangles were similar before I could set up my ratio to solve there. All right.